So I'm here at SP3 with Brett in the beautiful San Jose, California. If you've seen some of the other videos we've been doing with them, you would have seen the amazing diamond cutting tools and all the crazy applications you can actually use diamonds in. And today with Brett, we're gonna dig into this little compartment behind me.
So yes, this is our current model 675 hot filament CVD reactor that we use to create diamond films.
Okay, now do you only use these internally? Do you sell these units out there? What is that?
So we make these for external sales,
Okay.
and we'll license our coating technology and get customers set up with their own coating lines if they're interested, in addition to running these machines ourselves.
Yeah, so either they can send you their things that they want coated, or you can set them up in-house to do their own coating.
Absolutely.
Okay, so let's learn a little bit more about this. You mentioned something about a hot filament. So
yeah.
What does that look like?
There are two main ways of making CVD diamond right now.
Okay.
One uses a microwave plasmas,
Yeah.
and that's a much smaller deposition area, generally used for single crystal diamonds, like gemstones. This machine has a much larger area, and it uses hot tungsten filaments. We run an electrical current through them. They heat up to over 2,000 degrees C. They glow red hot.
Yeah.
And first we have to evacuate all the air out of the vacuum chamber.
Okay.
And then we backfill it with a mixture of hydrogen and methane.
Oh.
Okay, and so methane CH4 is the carbon source that will actually be the feedstock to form the diamond films.
Okay, now we're at SP3, so it's important, I think, for the people out there to not confuse this with SP2. What's the difference between those two? Okay,
so when you're talking about pure carbon, you have different forms. There's graphite, like is in your pencil lead, that's very different than diamond, the hardest substance around. But even though they're both carbon, they have different molecular bonds between the carbon atoms. sp2 is for graphite, and sp3 is the type of bond that is formed within diamond. And when you have something like DLC, it's somewhere on the continuum in between. So it has a lot of mixed phases, and you don't get the full benefits that you do with pure sp3 diamond.
Okay, so for anyone that's watching out there, they might have tried SP2, they thought they were trying real diamond. There's actually a difference.
Yeah, DLC and CVD diamond are very, very different products and different applications for the coatings.
So how big are your units right now, and is it limited to this size, or what's?
So right now in this machine, we can coat substrates up to about 12 inch by 12 inch.
Okay.
You know, which can be hundreds of tools or inserts, or maybe it's only one part if you've got something really big.
Okay.
We're also working on developing a new chamber, the 975, that will coat up to 450 millimeter or 18-inch parts.
So you're adding, that's like 50% capacity?
Exactly.
That's amazing.
All right, and Arthur, we have a couple of these machines in our lab running right now if you want to see what they look like when they're operating.
How can I actually say no to that, Brett? Let's go check it out.
All right. All right.
So Brett, man, we're back here. This is really hot, so probably, I mean, it's
pretty warm, yes.
Yeah, it's warm. Yeah, that's better. It's not burning me. I could probably, no, that's about my limit. But what's going on inside of these chambers? I know we had a little bit of a look out there, but what's going on right now?
So this chamber is currently running, and we are growing diamond films inside.
Oh, wow.
If you look inside the window here, you
Yeah.
can actually see the tungsten filaments glowing red hot.
Yeah.
They're over 2,000 degrees C.
Oh, jeez.
And that's hot enough that it actually chemically activates the hydrogen and the methane that we feed in. And it cracks the molecules apart to create very reactive components called radicals.
Okay.
And so these will float around inside the chamber, and when they hit the substrate, such as a cutting tool, they will stick and grow diamond. And you've got carbon within the methane, CH4, that's the feedstock, the source of the carbon.
That allows it to bind to the tool.
Exactly.
That is And obviously, I mean, we did another video. You guys can check out all the applications for diamonds. So it's not just the cutting tools going on in there. But I mean, this is an aluminum housing. How is it not melting down right now?
Okay, so there's a lot of power in here, up to 30 kilowatts of power going through those wires. So we have to use a lot of water cooling. All the aluminum chamber surfaces have water running through it to keep it from melting. Otherwise, this would just turn into a lump at these power levels.
It'd be a very different picture right now.
Absolutely.
So what's going on the backside? Is that what's going on back there?
So the backside, we have a patented tensioner mechanism that actually keeps the wires taut throughout the process. There's some complications that go on with the wires that happens during the process. And so to keep the process consistent, you need to keep the wires straight, and so we have a device that pulls on them.
Okay. So, and obviously you've got it dialed in for your in-house operations here.
Yes.
If someone buys a reactor from you, you help them get this all going?
Yes, absolutely. We go and install it. We'll work with them to develop their application. We have an R&D team here where we can develop the tooling and the exact recipes, the conditions where we operate these machines to grow exactly the film of diamonds that our customer wants.
That they need. So it sounds like if they have an application where it makes sense and they start that relationship, they're going to walk away with the solution if it makes sense.
Absolutely.
But only if it makes sense.
Yes.
Perfect. Awesome. Well, thank you so much, Brett.
Thank you.